Hi! In this video you'll learn the very basics of REST and HTTP, the basis of modern web APIs. So this video is an extraction from my Udemy course on key terms and concepts in software architecture and design, which you'll find in the description below. But now, without further ado, let's get started right away. Welcome back. We'll continue to focus on synchronous communication between two software systems, but we'll look at a style that allows for significantly less tight coupling and is so prominent that all of us are likely familiar with it: REST, the architectural style of the World Wide Web. As mentioned, this style also relies on synchronous communication between two software systems, but it differs significantly from RPC in many aspects. Entire books have been written about REST and there is much to say about it, but I would like to deliberately limit myself to core elements and, in particular, highlight the context in relation to other communication styles and emphasize when REST is a good choice and when it might not be. So, one of the fundamental principles of REST is its focus on resources. Here, a resource is understood as a logical entity, that is, something that the application manages or makes available to its users. In the insurance example, this could be something like a customer or an insurance product. In REST, resources always have a representation, that is, a format that makes a resource visible to the caller. A broadly used format here is JSON. Each representation has its own content type in the HTTP protocol. For JSON, this is, for example, application/JSON. These content types are strictly defined in the HTTP protocol. This also applies to many other aspects of REST, but we'll get to that later. In contrast, RPC focuses on methods that another application calls to perform specific, previously individually defined actions such as load customer data or calculate price. Such methods do not exist in REST. Interaction with these resources are also standardized in REST. There are specific actions through which the caller can interact with these resources. Furthermore, there are no individual methods on the resources that could be used in the sense of RPC. The available actions are defined in the HTTP standard with fixed semantics and are specified by HTTP verbs such as post, put, get, delete, etc. For example, a GET request retrieves a representation of a resource. Put creates a new resource or modifies an existing one, and delete deletes a resource. RPC typically also uses the HTTP protocol, but only as a transport protocol, whereas REST utilizes a full range of HTTP with generally defined standards. These HTTP verbs, defined in the HTTP standard, are therefore also referred to as a unified interface and enable applications to communicate with each other via standards without first having to define an individual contract. This is one of the key factors behind REST's success and, at the same time, the reason why the World Wide Web can function the way it does today. Imagine if every browser had to know the contract of every resource on the internet in advance in order to communicate with it. Unthinkable. Another feature of REST in this context is the linking to other resources, also known by the property called HATEOAS. Essentially, HATEOAS refers to the property that the user of a REST API does not need prior knowledge of the exact API, but rather that the server, along with a resource, provides additional links indicating what else is possible with that resource. Let's take a customer's data as an example. If a client requests data for John Doe, the server could also send links to additional resources or actions for interacting with the API. Possible examples here include a link to all of the customer's addresses, or to the customer's existing insurance policies, or perhaps even a note on how to modify the customer's data or how to delete it, for example. As a result, the client does not need to know in advance what is possible with the resource under which URLs, which in turn enables a significantly looser coupling between applications. Furthermore, REST and HTTP are present in virtually every platform every programming language and every technology today so that any application can be connected via REST to any other application that also understands REST. As I said, REST is the foundation of how the internet works today, and the fact that you can watch this course, this lesson here in your browser is thanks to the way REST is designed. So by their very nature, RPC and REST are both synchronous communication models, and the question is, when is REST appropriate and when is RPC a better choice? As always, this depends on the quality requirements placed on the systems involved or on the overall system landscape. Certain quality requirements can also be defined at the level of a company's system landscape. For example, a corporate strategy might require that all applications within a company be able to communicate via defined standards in order to achieve maximum efficiency and synergy effects when digitizing new business processes. In this case, REST clearly demonstrates its strength. REST effectively defines a global standard for communication between software systems, allowing new applications to be quickly integrated into the application landscape. Due to its widespread adoption, this offers a very high level of investment security, also because the REST principles are generally well understood and there is therefore a broad base of knowledge available. On the other hand, standardization means that communication between two applications is not necessarily highly efficient in terms of performance or response time. Resources must be converted into the requested representation format, often JSON, and then again read on the other end, which introduces a certain amount of overhead. While this overhead is usually not very significant, it might be a major disadvantage in performance-critical processes. In such cases, RPC approaches with binary transmission and the options to even stream data, for example via gRPC, are often more suitable. If you find that your system can be well represented as a collection of resources with which you can interact in a CRUD-like manner, REST is also a natural candidate for you. On the other hand, if you find that more individual specialized interface contracts are needed and you don't necessarily have to connect other systems to the same API, RPC could be a suitable candidate. The complex calculation of prices based on a complex model might be a good example on that. As is often the case, there is no right and wrong here. When writing REST versus RPC, quality requirements for the entire system plays a role, as they often do, and these should be known in advance to make an informed decision. Beyond synchronous communication, there are other integration styles you should be also familiar with. We'll look at one in the next lesson, so see you right after a short break.